Hi, hello everyone. This is Ajay Kumar, an application engineer reference from Aegis Computers. Today we are going to see a good topic, how an effective design solutions for the material handling equipment manufacturers. How the material equipment manufacturers, the fabricators, face the common challenges day by day by increasing the product quality and the reliability of the product they design the manufacturer, and they keeping the customer satisfactions consistently. So these are the things, and entering into the market very fast because it is a competitive global market increases. We have to push ourselves, taken the project into the market very fast. So the responding to the quotations and the outcoming of the project. So in the between these things, the automating the designs, the mechanisms, the weight and cost reductions for the load bearing members acting on the different structures. So these are the common challenges, and how to overcome these challenges through a SolidWorks is the agenda of today's presentation. So to design a part, design a assembly and the generation of the 2D drawings, the easy communicable sheets that must be shared between the designers and the manufacturers must be a perfect one, and it should be 100% easy understandable. So how to design a part and how to make those parts into an assembly environment, and the creation of generation drawings that we see one by one. Actually this is a SolidWorks environment, and actually I'm going to focus on the forklift where the different sets of mechanisms act here. I'm going to design a bracket, a steering bracket here, focusing on the wheel alignment between the centers of the machines. So here actually this is the steering bracket where the important part focus. So let us show you how to design a part and how to make a part assemble with the other components, the relations, creations, and the 2D drawings for those created parts and the assembled one. So before I start up a sketch, a 2D model, I just deleting this component and show you how to recreate the model here. For a reference, I'm just copying the pin I need and deleting the component here. So let me design. Before entering the design, I just need a parameters to design the model. So here I'm just measuring the two distance for this 31.80 mm is my main distance, and the inner diameter of the bracket I should maintain is 10.1 mm. So these two parameters is enough for me to design the bracket. So here let's start up with a sketch. It is similar to a 2D drawing design CAD. How for an example, how the AutoCAD and the draftsheet tools we design the 2D sketch, similar the SolidWorks 3D CAD enable the users to design. Here the automatic relations can be easily suggested through a SolidWorks, so that the designers can feel more comfort while designing. Let they focus only on the design, not on the tools. So here the basic building model of a product is a 2D sketch. So I'm designing a 2D sketch. What are the dimensions I need? So here I'm just maintaining the diameter of this is 31.75 mm and making the 2D sketch of the entities. Here you can see that the line sketch, as I told, the relations, it automatically takes me the best suitable relations for the two entities, like the coincidence, the concentric, if it is a line, whether it is in horizontal directions or the vertical directions, or the circle and the line, the tangency should be maintained. So these kinds of different relations it automatically suggests through a SolidWorks. And SolidWorks 3D CAD is a parametric software design, so we can able to change the design changes then and there. The working on the toolsets is also very easy and comfort, so that the designers don't want to stress themselves to work on the SolidWorks 3D CAD, that they are enjoyable while designing. So see how fast I completed my designs. By after completing the 2D sketch, you can find that since it is a cylindrical component, I revolved into 360-degree rotations. In suppose in case of any additional projections we need, can also easily done in the predefined sketches. And for an example, I am just creating the design on the above layer of these models. These references can be easily done in the predefined sketch, so I don't want to recreate my sketches again and again, so that the design time can be easily reduced by working on the predefined sketches. So I'm just extrusion of this part with the bidirectional. The scaling can be done automatically, and here I am just making the 31.50 mm dimensions. These sharp corners can be easily avoided through providing of chamfers and the fillets. Here let I maintain the fillet radius of 5 mm in the upward directions as well as the lower models. So the material I apply, how I told in the PPT, the material, real-time materials, not only the metallic materials, also the non-metallic materials like wood, rubber, plastics, glasses, etc. Here, for instance, I just want to apply the materials, the alloys, the ASI 1020 or the 304 for the sheet metal components, the alloy steels, etc. And the each property of each material can also be retrieved, and it will be definitely useful for the research process. The mass of my component for the alloy steel is 117.47 grams, so that I can easily taken the component weight in the design stage itself. So this will be more helpful for the fabricators to focus on the weight reductions or the weight additions of the projects. So after I am completing the part, let us show you how those design part can bring into the assembly environments and make the assemble between the two components or the assemble sets. Here I just want to maintain the bracket rod between these two gaps so that the width mate automatically suggests me the best relations of the mate and the coincidence of mate. The like simply clicking on the tools where I just want to mate, and SolidWorks suggests me automatically the best mate, and just simply clicking is the only job for the designers to work in the SolidWorks 3D CAD. So see how fast I can complete the project we do, and let us show you the next thing is how to create a 2D drawings for the 3D model. So what are the product we design in 3D model? The EC communication tool is the 2D drawings. So the 2D drawings must be 100% perfect so that the errors can be easily reduced, and the documentations must be perfect and maintained in a right way. So the different sets of tools in the view palette, on the right side you can see that different kinds of views that automatically suggest by the SolidWorks 3D CAD, and just simply placing the views is the only job for the designers. And the views I place, and next my job is to make a dimensions. The 2D draftings is my job, and that job can also be done automatically in this SolidWorks 3D CAD. So let's see if you can see that how fast I completed my 2D drafting for the views, the respective views. The alignment can also be automatically done by simply clicking on the tools, and the distance of the two dimensions can also be controlled. The added benefit of SolidWorks 3D CAD drawing is we can transform the sketches, the dimensions where I need. I don't want to make a dimension, I don't want to create a dimension again and again. I can simply switch over the dimensions by simply dragging and drop. The tolerance, in case of any tolerance I should maintain, can also be done through the different kinds of, either it is a bilateral tolerance or the symmetric tolerance, etc. So it is a very useful and customizable so that the designers focus only on the design and not on the tool sets. The property manager appears is also very helpful for the designers to control everything in the designs from the beginning of the project to the end of the project. Here in the title block you see that the details automatically retrieved through the part I design, the weight of the component or the material I apply. So the next thing is I show you how the more and more we can work on the SolidWorks 3D CADs. And the easiest communicable way is the explosions. I can make an explosion sets of the assembly model. Actually, this is a sub-assembly model. I can create an animations like how to assemble the components. So this will be definitely useful for the manufacturers so that they can avoid the errors while assembling, and the assembly time can be reduced so that the work on the more and more projects in a day. Let's say for an example that two assemblies they do in 2 hours, and they can make those 4 assemblies in a 2 hours. So the projects can be increased and the time can be reduced. And the next important thing is the fastness, the toolbox. So the standard toolbox items is available defaultly in the SolidWorks 3D CADs, whether it is a bearings, the bolts, screws, with the different kinds of country standards, and the whether it is an Indian standards or the American standards or the German standards. What are the standards? It never mind, we can easily make it. So just simply clicking on the location where I need and making a populate all tool. So it this SolidWorks takes me to the environment where the toolbox I configure, and it provides me where are the places I need. It automatically chooses the best standard where the tool I make, and the holes the it definitely useful for the purchase departments or what kinds of tool standards they should buy. So here you can find that the different kinds of standards, and SolidWorks automatically takes me the best suitable standards automatically. So here you can find that the fastness that automatically seated wherever the location it needed. So it provided each and every details with the different standards. So this is the best kind and the more helpful for the metal handling manufacturers. The toolbox they feel they designs. So the next thing is I'm going to show is the decision of shaft and the making of assembly sets, the motions play. Actually, it's everyone know that this is a forklift model, and let me focus on the design where some other relations can easily done in this forklift. Actually, some of the relations I have to made is you can find that there is a misalignment of the frame between the two frames. So here I have to make an alignment between the two brackets is should be maintained automatically. So the problem I do, it can automatically taken me the two different sets. As I told, it takes me automatically the two relations of the bracket, the frame, and the concentric. Since it is a concentric, so it takes me automatically so that the lift, the height of the frame and the movement of the frames can be easily adjustable. So see how the actuations, this is what I told, the actuations, the real-time actuations I do in my manufacturing, the prototypes or the model I manufacture. So the true actuations can be easily done in the design stage itself. And let me show you how the drawings for the 3D CAD models. Now, before we find that the 2D part drawings, and let us show you how the assembly can be easily communicable for in the by the way of producing the 2D drawings. Actually, again, the simply the view palettes automatically makes the users to show the different kinds of views, and my only job is to simply drag and drop into the location where I need. So here I just want to represent the right side view, that is the side view of the model, and the 3D model I want to communicate, and the scalings can be easily done so that the sheets can be fulfilled with the easily understandable and the full perspective views. So the things we can do is everything is very customizable so that the tools are very much of easy for the users to understand and work in the 3D CAD. Here I just want to show the alternate position view of this forklift model so that I can do also the different positions, the frame positions. And for an example, I just want to make the frame position downward so that the alternate position I just want to communicate to the shop floor people, that also I can able to do. You can find that the different alternate positions. And obviously the next thing is the bill of materials. The main important thing of the automatic generation of bill of materials is a uniqueness of the SolidWorks 3D CAD. The simply clicking on the bill of materials tools provided me the clean understandable details about the product I design, and the item numbers, the part number, and the quantity I need. And not only this, the material I apply for each components can also be provided in the bill of materials, and the component preview can be easily done for the individuals. See, I'm just simply moving where I need, and the component preview can be done one by one. So this can be directly printable to the shop floor people, and the ERPs, the resource planning softwares, can also be connected directly so that the documentations the can be maintained 100%. Next one is the important thing of the automatic balloons. So first I mentioned the bill of materials 3D CAD, and then the bill of materials, and those individual property I want to find where in the assembly, so that here to avoid those misunderstanding I can provide the automatic balloons. So automatic balloons takes me to create the item numbers where it is necessary and locates the place automatically wherever it need. The directions can also be done, and by using the magnetic lines, the automatic balloons can be easily scheduled and arranged within a easy manner. So the arranging of automatic balloons is very much of easy. See how quick I am just making the part design and the designing of the 2D drawings of the single part, and brought that model into an assembly and assembled with the automatic relations suggested by the SolidWorks and bill of materials for the whole assembly setups and the automatic balloons. Here the similar way the title block can also be filled automatically through the materials I apply for each individual parts. So the next thing I just want to convey is the main important thing is the actuations, the motions. The animations can be easily done within the SolidWorks itself, so that the again the communication tool is a more powerful one, so that the customers can get the document through an animation video. So we can generate a video of these animations within the design stage itself. So these are the some of productivity tools that we can do is. And the next one is the assembly visualizations. The each file name, the quantity I introduced in the SolidWorks 3D CAD, and the mass of the each components, what will be my weight of the each components, so you can find and can be automatically sorted by simply clicking on the tools, and the color can be easily provided so that the identifications that the different sets of bodies which I have introduced is always 3D CAD, and the mass, as I told, the mass of the individual components, so I can focus whether I just want to reduce my mass of the component or to increase the components, or I mean the thickness of the component. And not only that, the density, the volume, the surface area, and more the custom properties, these are everything is a customized one. And what are the thing I need, I can bring it over there regarding the 3D softwares, 3D modeling. So here again I am coming to the important topic is the detections, like the any interference between the two components. It is really helpful for the material handling equipment manufacturers to rectify the details, to rectify the errors, to reduce the number of prototypes, to reduce the number of prototype cost, to reduce the material wastage. So everything can be easily done by evaluating the product I design in the design stage. Any clearance, what clearance should I maintain in the designs with between the two shafts, between the two components, or the interference, any interference is there, if it is an interference, where it is an interference that occurs, so that I can everything I can rectify within my design stage. And the whole alignments, whether it is a misalignment holes I made with my design, that allocated dimensions, the specifications of the model, and the deviations, any deviations, as I told, any misalignment deviations are there, and where it is any, if it is a deviation, where it is. So everything we can evaluate my product in my design stage. And another important thing, the whole weight of the sub assembly. The mass 26,566 grams, that is nothing but the 26 kilogram of this subassembly part. So let me move on to the PPT on concluding the topics we discussed until now. And by using the SolidWorks 3D CAD, the goals that can achieve is we can create the mechanical designs more efficiently, bringing the ideas into concept without any limitations, reducing of the material wastages, number of prototypes and cost can radically reduce, and generation of bill of materials that connected with the ERP or the purchase departments directly from the design 3D CAD software to the purchase departments and the documentation purposes, and the cost can be reduced. The project success will be in your hand in the competitive global market. Thank you.